All right, you guys, we're going to wrap up our conversation talking about the properties of logs by discussing the change of base formula. So the change of base formula says if a does not equal 1 and b does not equal 1 and m are positive real numbers, then log base a of m equals log base b of m over log base b of a. So our calculators, okay, only have two log buttons, which is the common log and the natural log. So typically, if we were to calculate something like log base 8 of 64, okay, we don't have a log base 8 button in our calculator. So in order to give an answer for something like that, we're going to have to use the change of base formula. The change of base formula allows us to calculate something using either the common log, okay, or the natural log to make that computation, okay? So if you have your calculator and you're not sure where those two buttons are, okay, the common log button is here next to the 7 on your calculator, and the natural log is right underneath it next to the 4 on your calculator, okay? So those are the two buttons you're going to be using. Now, whatever version of the change of base formula you'd like to use, it doesn't matter. You can either use the common log version or you can use the natural log version. Each version gives you the same exact answer, so I would just suggest whatever one you like, stick to it and use that one. For me, anytime you see my work, more than likely I'm going to be using the natural log version only because I like to write ln in cursive. No other reason, that's the only thing why. Okay? All right, so let's try to use these in a problem. All right, so this tells us to approximate, okay? So they want us to approximate a, which is log base 5 of 89. So approximate, even if you forget, is your key word to use the calculator, okay? Because you're rounding, okay? So I'm going to write our problem, log base 5 of 89. Okay, so remember, I need to use the change of base formula because I don't have a log base 5 button on my calculator. So I can use either one of those versions. So I could convert this using the common log, saying, okay, well, this is equivalent to log of the argument over log of the base. Or I could use natural log of the argument over the natural log of the base, okay? Now, when I put that in the calculator, okay, it's going to look like either one of these. So if you use the common log version, it will look like the one on the top. The natural log version will look like the second one. And you can see you get the same exact decimal. So they told us to round to 4 decimal places. So our answer is going to be 2.7889. Okay. Now, for these types of problems, be careful how they want your answer. So in this particular problem, they told us to approximate. So this is the approximation, the decimal, okay? But if they were to ask for the exact answer, you would either give them the natural log version or the common log version, okay? So it just depends. If they want the exact answer, they want the log in your answer. If they want the approximation, they want the decimal, okay? All right, let's try the second one. So we have log base square root of 2, square root of 5, okay? So you can either use the change of base formula in the common log or in the natural log version, okay? Now, no matter what answer or which version you give them, okay, if they were to ask for the exact answer, you cannot leave the square roots in the answer. Okay, so when we were expanding and condensing logs, remember anytime we saw a square root, we converted it to a rational exponent, which was a half. And we know that powers for logs can come to the front. So this will give us 1/2 log of 5, 1/2 log of 2, and the 1/2s would cancel, which would give us log 5 over log 2, Okay. Now that would be the same exact thing for the natural log version, so it would end up being natural log of 5 over natural log of 2. So remember, if they want the exact answer, you would give them either one of these. But if they ask for the approximation, you give them the decimal. So when we plug it in the calculator, our decimal turns out to be 2.3219. Okay, that's the approximation. Cool. So just be careful of what they're asking you for so that you give them the right version of the answer. And that's it for that section.